Hello everyone, I'm Pranitha. This is a basic video to the introduction of the latest software technology, Docker, which gained a lot of popularity as soon as it released. This is the official logo of the tool. So, what is a Docker? Docker is an open source tool to pack, ship, and run any application as a lightweight container. That is, it can package an application and its dependencies that can run on any server. This helps enable flexibility and portability on where the application can run, whether on premises, public cloud, bare metal, etc. And now another question arises. What is a container? Unlike a virtual machine which provides hardware utilization, a container provides operating system level virtualization by abstracting the user space. Using containers, everything required to make a piece of software run is packaged into isolated containers. Containers do not bundle a full operating system. It only bundles libraries and settings required to make the software work. And this makes efficient, lightweight, self-contained systems, and it guarantees that software will always run the same regardless of where it's deployed. This is the overview of where Docker and container are placed in hardware. Why do we require container? Containers are a solution to the problem of how to get software to run reliably when moved from one computing environment to another. A container may be only tens of megabytes in size, whereas a virtual machine with its own entire operating system may be several gigabytes in size. Because of this, a single server can host far more containers than virtual machines. It also ensures that software will always run the same regardless of where it's deployed. Containers are actually far from new. There are many containers used by different companies. Google has been using their own container technology for years. Other Linux container technologies include Solaris Zones, BSD Jails, Alexei, etc., which have been around for many years. Though there are many container technologies, why Docker all of a sudden gaining steam? Well, the reasons are ease of use. Docker has made it much easier for anyone, developers, system admins, architects, and others, to take advantage of containers in order to quickly build and test portable applications. It allows anyone to package an application on the laptop, which in turn can run unmodified on any public cloud. And speed. Docker containers are very lightweight and fast. You can create and run a Docker container in seconds compared to virtual machines which might take longer. Next is Docker Hub. Docker's users also benefit from the increasingly rich ecosystem of Docker Hub, which you can think of as an app store for Docker images. Docker Hub has tens of thousands of public images created by the community that are readily available for use. Next is modularity and scalability. Docker makes it easy to break out our application's functionality into individual containers. Portability across machines. It follows the principle build once, run anywhere. It prevents flawed applications from compromising the rest of the system. Applications can be easily and fastly removed or added. It reduces the cycle time of development, testing, and deployment. It always supports users with an active community. And this is how the deployment of Docker is done. Docker example, let's assume you are working with a group of data scientists who need to perform a number of ad hoc analysis projects. They like to use core set of tools that include Python and related data analysis packages along with the statistics package R. Depending on the problem at hand, they like to install other tools as needed. Rather than to keep a single Linux environment that works for all the cases, the data scientists have decided to build a base Docker image with core tools. They will deploy and add tools as needed for each of the specific projects. Now, the system administrator builds their basic image starting with the Docker search command to find an Ubuntu image in the Docker repository. After downloading the latest version of Ubuntu, the system administrator uses the docker run command to execute the Ubuntu image. The attach command is used to connect to the virtual instance and run commands. From there, the system administrator downloads and installs the Python and R tools needed using the same commands someone would use on any Ubuntu instance. The last step in the process is issuing the docker commit command and specifying the name of the image to save as a Docker image file. This will save a specification for the Ubuntu operating system plus the packages installed. Docker is the best known container management solution till now for its integrated, tested, and certified platform. For further references, you can visit www.docker.com. Thank you.